Prove the limit using the epsilon delta definition of a limit. Epsilon and delta explained. Prove the limit using the epsilon delta definition of a limit. The limit of 8 plus 2x over 3 as x approaches 5 equals 6. Now this is not meant for direct substitution. Of course we can, but we are here to explain and apply and use the epsilon delta definition of a limit. So let's get started. The limit of f of x equals L as x approaches a. As x approaches a, where a is right here, the values of f of x will approach L, and this is L right here. What does this mean? If for every epsilon greater than 0, a small number, that epsilon is up here, given epsilon, that's like given, for every epsilon given to me greater than 0, there is a corresponding number delta greater than 0 down below right here, such that all the distances, instead of reading it as absolute value, the distances away from A with a radius, within a radius of delta, as you could see right here, this is A plus delta and A minus delta. That is the same concept as this. The interval from away from A with a radius of delta. Then, if we are picking on x's within this interval, then we have f of x minus L, absolute value less than epsilon, meaning everything right here will be within this interval. The interval that goes from L minus epsilon to L plus epsilon. This might not still be clear, but it's a great concept. Meaning, imagine if you pick an epsilon 0.0001. So you're trying to be close to L, and I find a corresponding delta that every single x within this interval guaranteed to be away from L, from right and left, with the number that I give you, the very tiny epsilon value. This is our problem, and we're going to use epsilon and delta. To prove the statement using the epsilon delta definition of a limit, I need to make a connection between this right here and this right here. Well, I could see that as x approaches A, here I have as x approaches 5, that says that A is 5. Since the limit is called L, and we have 6, that's my L. So in our problem, A is 5, and L is 6. Of course, that is my f of x. So f of x is 8 plus 2x over 3, which is a straight line. To speak epsilon and delta, looking at our function and our limit, we will do the following. Given epsilon greater than 0, we need delta greater than 0, such that instead of A, I'm putting 5 that we agreed on. We need x's within an interval of radius delta away from 5. All these x's will guarantee that the outputs, which is called f of x, away from 6, our limit, will be less than epsilon, meaning all the outputs will be in the interval 6 plus epsilon and 6 minus epsilon. That's just like a connection, but still we're not proving it yet. Most books uses the following method. If I use this method for the first time with my students, by the end of the problem, they kind of like look at me like, are you done? I could see it in their eyes, they're not fully convinced. Well, epsilon delta concept is a great concept, but you cannot fully understand and start applying it to problems just by seeing one example. So you need to see the example, you need to practice more, and maybe revisit the steps. Try to connect where you started and where you finished to see what's happening and what's going on with delta and epsilon. Let me show you the regular way, which is the book's way. Then I'll show you a different way that kind of in detail explains what's happening with epsilon and delta. So remember, epsilon is given, delta is missing. Delta we will find that corresponds to epsilon that will be given to us. So we need to prove this. But to prove this, I'm going to start with this side because epsilon is given. 8 plus 2x over 3 minus 6, absolute value less than epsilon. Combining the fractions inside, I'll end up with 2x minus 10 over 3. Just by rewriting 6 as 18 over 3 with a common denominator so I could combine them. That's pretty much it. After that, I could see that 2x and 10, they both have a common factor, which is 2. So I pull the 2 outside, factoring between 2x minus 10 and taking the 2 outside. Now this 2 and this 3 could be taken out of the absolute value, just like this. As you could see, I have 2/3 outside. Now what happens is I'm going to multiply both sides by 3 over 2. You might not be able to follow me if this is your first time, going like, why you're doing this? Like, you know, where are you taking us? That's my main point. As a first time, seeing epsilon delta and seeing a proof or an example with numbers like this one here, you start wondering like why you're combining fractions, why you're taking the 2/3 out, why you're getting rid of the 2/3 by multiplying by the reciprocal, just like this. The reason why is the following. Now we choose delta equals 3 over 2 epsilon. And that's exactly what we want. This right here looks like this one here. So all what we are doing right here, going down, is trying with this form that we're given epsilon, trying to get something that looks like this. We need an x minus 5. Once you compare this with this back and forth, you could tell me that it looks like the right hand side is delta here and the right hand side is 3 over 2 epsilon. And that's why we say we choose delta equals 3 over 2 epsilon. Then we say the following. If this is given to me, if I have x's away from 5 within a radius of delta, that will give me this for sure. And we say that we're done with the proof. Thus the limit of 8 plus 2x over 3 as x approaches 5 is equal to 6 by the definition of the limit. And we're done. And this is my point. It looks like a little bit confusing, but if you revisit and try again and make a connection, it does make a lot of sense, especially if you want to graph it. But here's another way, at least if you see it once, I'm sure you're gonna have more confidence in the proof. So here's the problem again. Rephrasing it, this is what we want. If x minus 5 absolute value is less than delta, then we need 8 plus 2x over 3 minus 6 absolute value less than epsilon. But I rewrote 6 as you could see as 81 over 3. So that is the same thing as this if and only if. That's for sure. I'm just going to keep going and rephrasing it. It's like I'm copying everything in the statement down below instead of saying then. That's if and only if. That means the same thing. So if you want me prove this, it's the same as if you want me prove this, which is the same thing as if you want me prove this. I combine the fractions, as you can see right here. So, but now I'm gonna simplify between 8 and negative 18 inside the numbers. And take a look. 2x minus 10. 8 minus 18 is negative 10. And I have the following. So again, this is if and only if. So I'm changing the statement little by little to show you the connection. I'm going to take the 2 out as a common factor on top. And now I have 2 times x minus 5 over 3. I will take 2/3 outside. If and only if. The following 2/3 is outside. Now I'm going to multiply by 3 over 2 both sides and leave x minus 5 alone. Now I see the connection. Almost there. Multiply by 3 over 2 both sides from here. I get the following. Well, that is a clear connection. If I want to prove this, it's the same thing as proving this. What do you think? Because I'm just simplifying and I'm writing the whole statement again and again. Well, comparing this right here with this right here, we could clearly see the connection. Instead of epsilon, delta, I have 3 over 2 epsilon. So we could say, let's choose delta to be 3 over 2 epsilon. Epsilon that you gave me earlier. Now, we also don't verify, but let's verify. See if this makes sense. I'm going to go backwards. As you could see on the left side, the main thing, after you do some problems, you'll notice that you start right here on the left and you want to end up here. But since epsilon is given, I try to make the right hand side that has epsilon communicates with this one, so I could choose delta. So I could pick on delta. And that's pretty much it. Let's verify. Now we already have delta. I just want to verify it. If absolute value of x minus 5 is less than delta, that means we're looking at x's away from 5 with a radius within a radius of delta. But we are replacing delta with 3 over 2 epsilon. Then multiplying both sides by 2/3 to leave epsilon alone, as you could see. Taking the 2/3 inside and simplifying inside, I get 2 multiplied by x minus 5 over 3. Distributive property, applying the 2, and I get 2x minus 10 over 3. We're trying to get to this right here, as you could see. Now, I could rephrase it and write 2x plus 8 minus 18 over 3. The reason why, because I want this. Breaking the fractions down, I have minus 18 over 3 and 2x plus 8 over 3. And that is now exactly what we want. So we started with this epsilon or delta equals 3 over 2 epsilon. Keep going, and that gave me the epsilon right here formula. So that's it. But we don't verify because we are confident that without writing all these steps, by knowing what you're doing, you start here, you start on the right side because epsilon is given, and you want to make a connection with the left so you could see what is delta. since this problem is mainly recorded for the concept of epsilon and delta, I want to support epsilon delta concept through a graph. Our problem is still the same. 8 plus 2x over 3 as x approaches 5 equals 6. It's the same problem. But when you look at f of x is 8 plus 2x over 3. And if you simplify it, you could see the slope, which is 2/3, and the y-intercept is 8 over 3. Now when the slope is 2/3, I could see from the line that we have a slope of 2/3. Take a look at this. From this point up to this point, that is a 2 and that is a 3. So it's rising 2 and running 3. I picked up a graph that shows clearly the rise and run, and I picked up 5 and the output 6 instead of 1, let's say, or 2 close right here to show the epsilon delta. 5 is right here, and that is my A. 5 will give me 6. So that's my L and that's my A. But we want to show that the limit exists, and as x approaches 5 within a certain distance, it's called radius, delta, everything will give me an output within an interval centered at L, which is 6, within a radius being called epsilon. Now because of the following, and as you could see right here, this is one more time 5 and this is 6, and this point is right here. We see the right triangle, it's going this way and going this way. So we are rising 2 and running 3. I don't want to write everything on this page. I'm trying not to, because I do have the notes written in the coming slide. So this is also a clear point, and this is also a clear point. So if I take it this way and I take it this way, I could see that I do have a clear interval that I could see clearly, which goes from 6 up 2 units and from 6 down 2 units. That's my L, and that's my L plus epsilon, and that's my L minus epsilon. So if I pick epsilon equals 2, that's this 2, I could clearly discuss graphically what is epsilon, what is delta. Now, if I take it from this epsilon that you gave me, which is 2 units, away from L, which is 6, go to the graph and meet the graph right here, this portion, and try to go backwards to the x-axis, and I see this point and I see this point. But this point is away from 5 by 3. And this point back 3 units will get to 2. So what's happening here is A equals 5, that's this 5, and this point right here will be the end of the interval, which is 5 plus 3, and this point right here will be 5 minus 3, and that is A plus delta, and that is A minus delta. Now there is even more than that. So if I try to see what's happening, if I take half of the interval on top, which is from 4 to 8, from L plus epsilon and L minus epsilon, if I just take 2 units, the reason why I'm doing this, because I want to show you the right triangle and the slope. So if I go back and I go down, I could see that epsilon, which is 2 units, this much is 2, this much is 2, that's the radius, epsilon, gave me back, going down, this much, which is 3. And that's the radius of the interval down, centered at A, which is 5. So that's my epsilon, and that's my delta. But if you notice that 2 is the rise of the triangle, and 3 is the run of the triangle. But in this case, that is my slope. My slope for this equation is 2 over 3, and I have m in this case equals 2 over 3. So if I give you epsilon, which is the rise, I need the run in this case as a line. Well, of course, if it's a curve, it's not going to be rise and run exactly, but that's a great concept to understand the concept or the connection between epsilon and delta. Let's see the notes. Here's the notes. One more time. If L is 6 and A is 5, we are looking at this concept right here. You give me any epsilon. For the convenience, graphically, I picked up epsilon to be 2. Why 2? Because clearly if I go 2 units up and 2 units down, I could see the right triangle that describes the slope. 1 is not going to be helpful in this graph because 1 is going to go kind of like from this point to this point, which is not clear. It doesn't meet exactly at a certain point that I like. So 2 is convenient. But from the graph, you could see that having an interval here with a radius of 2 centered at 5, because that's my 6 plus 2, and that's 6 minus 2. Or 6 plus epsilon and 6 minus epsilon. Using the color shaded, you could see that if I go back, meet the graph, and go down, I see my interval down below. But the interval down below is actually describing A plus delta and A minus delta. And that is clearly delta to the right, delta to the left, adding delta and subtracting delta. So delta is 3. What do you think? That is clear. And if you notice right here, that's what we came up with. Delta equals 3 over 2 epsilon. Delta is 3 over 2 epsilon. 3 over 2 is not the slope, it's the reciprocal of the slope. And that says that delta is 1 over m times epsilon. 1 over 2/3 becomes 2/3, 3 over 2 times 2, 2 cancels, we end up with 3. Why you do all this? There is no need. Just see it from the graph. If epsilon is 2, delta is 3. If epsilon is 2, 2 cancels with this 2, you end up with delta equals 3. That is, I think, a great concept to see the relation between epsilon and delta, as this argument says. You give me any epsilon, doesn't have to be 2, could be 0.01, 0.001. Corresponding to that, I could find delta that guarantees that everything you take here will be forced to be here. And that should do it. Thank you.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.